Hello, everyone. Welcome back to this new section. So, in this one, we will be talking about functions, and by functions, we are talking about quadratic, hyperbolic, exponential. We're talking about trigonometric functions as well. Yeah. So, yeah, we're gonna talk about trigs as well, trigonometric functions, and then that'll be the end of this section. And yeah, this video we are talking about quadratic equations. It's everything from grade 10 building up to grade 11. Some of the most important things you have to know, not actually some, all of the important thing you all have to know. And yeah, as you know, at the end of every recording, we will do a question covering all the topics. So let's get started. Right. So in grade 10, in grade 10, this was the form that we knew. Right? I think this might help. Yeah, this was the form that we knew, right? And yeah. And the thing is, with in most examples that you did in grade 10, you'd find out that most of them B was 0. So you had something like this instead. You had something like y is equals to ax squared plus q. You had something like this for most of your problems, right? But yeah, I just added the bx, you know, just for generality, just to generalize the whole quadratic equations form, right? And one thing we did was say, most importantly, because most of the examples you dealt with, there was an a involved and a q involved, so it was important that you guys know what does an a does to the function, what does a q does to the function, right? um yeah, so remember here, everything I'm saying here is for parabola, ne? Is for parabola. So what is q, right? Q can be categorized for many things in a parabola, ne? um yes. So let me see, where do I start with q? Okay, so number one, q is it tells us about the vertical shift, right? Let me just start with that one. Vertical shift. Yeah, our q is going to tell us about our vertical shift, right? Yes, it tells us about the vertical shift. If it's positive, it means we shifted q units upwards, and if it's negative, it means we shifted q units downwards, right? And there's something about the shift that I should say. The shift is actually always, damn, I'm still struggling with this. It's always from the origin. So hope this will fit from the origin. So it's always from the origin when we are talking about a shift, it's always like from the origin, unless then you already have a graph which has been shifted. So the shifting from the origin has already happened, and then on top of that we tell you of another shift that comes. So then that second shift that comes, it will shift not from the origin but from the point our graph was at that point in time. Yeah, but this is some lessons for later. So also we can talk about, remember now this is a parabola, only in parabola, and so there are some things we're going to mention about q that are going to apply to all the other functions. But yeah, uh some of them, just remember, they will only be parabola specific. Cool. Q is, we can say for q is our, oh, I almost said something which was so wrong. It's the y value of your turning point. I'm just gonna say TP. It's your y value of your turning point, right? Yes. So I think these are the most important ones. I'm trying to think to see if I'm missing anything. But yeah, if I did miss something, I'll just come back to it. But yeah, the most important one is the vertical shift, right? Is the vertical shift. And here the sign is just as it is. If you have a function, let me use a different color. You have, say, g of x is equals to 2 x squared plus 4 plus 4. What does that mean? It means that your graph it shifted 4 units from the origin upwards, ne? Because it's positive 4 here. So in that case, say I have my origin right here. Of course, these are my x's, my y-axis, x-axis, and this is my graph, right? Not drawn up to scale, guys. Not, maybe I can do something. Let me see. Yes. Yeah, no, I knew I could cook up something here. So yeah, here's our graph now drawn up to scale. It's like this, ne? But now this plus 4, it tells us that our graph shifted 4 units above the origin, right? So now this one, the g of x, it's going to be something here. Maybe I can do this. Select, copy, and then I paste, then I just move it correctly. Yeah, and then maybe I can also color it. Right, nice one, nice work. So yeah, so this is now g. It has shifted up. This point right here, it's gonna be 4, right? Yeah, it's gonna be 4. All right. Do you remember when I said I almost said something wrong? I was about to say that it's your y-intercept, right? I was about to say it was your y-intercept, and that was true. That was low-key kind of true. No. It was the truth, right? No. It is. It is your y-intercept. To think about it. Exactly. No. I was right. Yeah, I was saying, man, if something there is something I'm missing, I will remember. Yeah, and I did remember. So no, that is very good. That is so cool to yeah, just remember. Yeah. So I'm gonna write it down here. It is y-intercept. Yeah, it's the y-intercept, because it's like when you look at this form that I wrote here, ne? Look at this form. What does y-intercept means? Y-intercept, x is equals to 0, right? So if x is equals to 0, we have 0 here, we have 0 here. The only thing we are left with is the q, right? Because then every other thing is gonna be what? Every other thing is gonna be 0. We go here, x is equals to 0, then this thing is gonna be 0 as it all, and then we are left with q again. So yes, I was right. So yeah, this is q, guys. This is q. Let's talk about a, ne? A, it's just very simple. A is your a is your gradient. Maybe not, let me not say gradient. Maybe let me accurately say that a, it tells us about the shape, right? So a, it tells us about the shape of your parabola. A tells us about the shape of your parabola, right? And we can have two possible a's, right? Because if a is equals to 0, then we are no longer talking about a quadratic. It's gonna be a linear, right? So if let me extend the line. If a is greater than 0, what does that mean? It means your a is positive. That means your parabola is gonna be shaped like this. And if your a is smaller than 0, meaning that your a is negative, you're gonna have a parabola shaped like this. And that's it, we are done, I believe, with the grade 10 things here. So yeah, there are just a couple of examples here. We're gonna expand our knowledge in based on what we have done. This is just a revision, eh? So yeah, if you were tasked to draw these to sketch these parabolas right here. Now it was gonna be quite easy, Yana, because the first one where I wanna so it's x squared, ne? So the y-axis it does, so y-axis x is equals to 0. It's 0.00. That's why the turning point is gonna be even the 0, 0. And remembering that we also said that is the y value of your turning point. Man, wait. Let me go back. Yeah, yeah. So you see this thing, you're like y is no, your q is the turning point, is the y value of the turning point. And this point, ne, this is very important. Now this is me giving you a little bit of what's in grade 11. So these two things, when we start doing grade 11 forms, they're gonna there are certain times when they will mean the same thing, and there are certain times when they will mean different things, right? Yes, that is so true. That is so true. With the forms we're going to do, just remember this, guys. Note it down, because I don't want, yeah, I don't want you guys to say I'm giving you wrong things. Just note it down. This is very important. Note it down and say that these two for grade 11, they can mean the same thing or they can mean different things. And we're gonna just talk about that. Yeah, man, so true. Yeah, we're gonna. That's very important, man. So yeah, here for number one, it's just gonna be something like this. There's really nothing, because the a our a is positive, so our graph will be smiling. It's the u-shaped, like we did say here. And yeah, it's just gonna, the turning point is gonna be there, the origin. So number two, the first thing we see, I'll say number one. Number two, the first thing we see is a negative gradient, right? With a negative gradient, we know our thing is gonna be what? It's gonna be a u-shaped, right? It's gonna be a u-shape. Now I'm lying to you guys. I'm lying to you. It's gonna be an N, because it's gonna be an N, because when it's negative A, then it's a N. Yeah, it's frowning. It's an N, not a U. U is positive, N is negative. So it's gonna be an N. But now also, ne, there is a -1, right? Which is, we know -1 is Q. What does that -1 mean? Remember, now I said this is the shift, they are from the origin, ne? So it's the graph, ne? From the origin 0, 0, our graph, it shifted 1 unit down by, yeah, it shifted 1 unit down. It shifted 1 unit because it's 1, and it's downwards because it's a minus. So it's gonna be, our turning point will be here, and our graph will just frown like this, right? And then yeah, you are done. Of course, this is your what, this is y equals to -1. Talking about the second one, no, the third one is quite interesting as well. Probably might need more space. This is x, y. So this one, it is negative, right? But the thing is, it shifted 4 units upwards. So we go 1, 2, 3, 4. Let me extend it up. 1, 2, 3, 4. This is 4. So this is my turning point, right? This is my turning point. So now when I do my graph, it's gonna be something like this. It's frowning because of a -2, and it's shifted 4 units upwards, so the turning point will be here, right? That was all in grade 10. Yeah, you guys can do more questions if you want some revision questions. I'm not gonna do that here. So let's move on to grade 12, no, to grade 11. Damn. So yeah, there are two forms for grade 11, two important forms for grade 11. The first one is this one. This is the first one. This is the first form. This is the first form, and it's very important. This form, there are many questions, and I mean the second form of grade 11 is not so difficult. But we have this one. Yeah, so true. If you're not aware, so you have to be careful here. If you're not aware, you can easily get things wrong. So let's talk about it, right? before maybe let's look, ne? Look at this form. Is there anything new, right? Is there anything new in this form from the previous one? Of course, the format is not the same, but is there any variable, anything that you see that you've never seen before in any other forms, of your parabolas? And I'm sure the answer is yes, there is. And that thing is P, right? I'm gonna write it down here. It's P, right? It's the thing that is new because we know A and we know Q. I mean X, we've been dealing with X, Y, we've been dealing with Y, but P is new, right? P is new. We have to talk about what is P, what does it do, and so forth and so forth and so forth. So P, in simple terms, P tells us about the horizontal shift. Horizontal shift. Yeah. So horizontal, what do I mean? Remember, vertical is up or down. Horizontally, then it's gonna be left or right. Right? Yeah. Um. Yeah. Let me see. Okay. Yeah. So and then with P, something that is a bit confusing is, that point P, ne, when you see it, I'm gonna make an example. I'm just gonna take this is just my own mind. Say y minus 2x plus 1 squared minus 5, and then I have another y equals to minus let me say maybe plus maybe 3x minus x minus 4 squared plus 2, no, plus 1. Okay, it's fine. So yeah, so yeah, I'm gonna talk about those in a minute. So P, like I said, P is a horizontal shift, let me think. And then another important thing about P, this is P. It's gonna be the negative x value of your TP. Yeah, it's gonna be a negative x value of your turning point, ne? Yes, it's gonna be a negative x value of your turning point. And this is, I guess, with this thing, it helps with the negative x. I wanted to address this then. So let's look at, this is number 1, this is number 2, ne? So I'm gonna have my x value, so these are my x values for my turning point, ne? X values for my turning point. I'm just gonna write it down here. Turning point x values, right? Yeah. So the thing is, there's that thing that when you look inside the bracket and you have a positive number, you're gonna write it as a negative when you write it on the outside, né? And if you look inside the bracket and you have a negative number, it's gonna be positive. You look inside the brackets and it's negative and it's positive, then it's gonna be negative. Like you see number 1 inside the bracket, we have a +1, right? But now when we write the x value for our turning point, which we get from P, we're gonna say what? We're gonna say that value is -1 because inside it's positive. And then also number 2, the value there is negative, it's -4. So we know we're gonna write it as +4. Just gonna remove this, right? So this is something, just know it and remember it. This thing is applicable also with the hyperbola. Yeah, with the hyperbola. Yeah, yeah, yeah. I want to say with the exponential as well, but actually, look here, I kind of forgot that. But we'll get to it when we get to it. So yeah, yeah, this is it, bro. This is it. Just wanna see if I'm not missing anything. The P is the vertical shift, of course, and the P is the minus value of your turning point. I mean, now, like, since I've already spoken about the Y value of a turning point and the X value of a turning point, I can just say turning point coordinates. It's gonna be what? We start with the X value, which is minus P, right? And then Q. Exactly. Right. So yeah, this is just it. And then axis of symmetry, the equation is x is equals to minus I was gonna say minus x, yeah, but this is so wrong. Let's write it properly. So to write it properly, we're gonna say x is equals to minus p. That's the equation of your, yeah. Yeah, so for example, let me draw a straight line with these two equations and say axis of symmetry. Axis of symmetry for this one is gonna be x is equals to minus 1, and here it's gonna be x is equals to plus 4, positive 4. All right, so we can now go back here and say p tells us about the axis of symmetry. Yeah, it tells us about the axis of symmetry, name that is p, period. And then with the turning point, we did already share some light on it, but for the turning point, there's something quite interesting that I want to show you. There's something quite important that I want to show you. Let's go back. Do you guys remember this thing of what is this thing, man? There's this thing we call completing squares. Completing squares. So we're going to use that to show you something and a little bit interesting. I think if you know this, it will help you in many areas. So let's start. You have your equation. I'll use red. Let me use blue. You have your equation y is equals to ax squared plus bx plus c. Cool. So now let us complete squares. On this thing. The first thing, you're gonna have to take out a, right? Because the coefficient of x squared, it has to be 1. It must be 1. That is why we are taking out a. Then here you have b over a x, and then you have c over a. Then the second thing of completing squares, what do we do? All right, x squared plus b over a squared. So you're gonna take the second term, which is the coefficient of the second term, which is what that coefficient is, right? And this coefficient you divide it by 2. If you divide it by 2, you're gonna end up with b over 2a. And then you're gonna square it. You square the whole thing, and then you're gonna add and subtract this thing. So we're gonna say plus b over 2a squared minus b over 2a squared. Then you have plus c over a, close bracket. And then you group the first 3 terms, and then the third step, you don't really need to think about this one. You don't need to think much about this one, because you're gonna write x. We look at the sign here, it's positive, so we have a positive, and then you'll take the number inside the squares, this number inside. I get you have your squared here, you're taking the number here. And if it happens that when you wrote I'll say this is step 1, step 2. If you wrote step 2 and you wrote it like b squared over 2, over 4 a squared. If you wrote it like this, then you're gonna have to write whatever that you did square to get this, and that thing that you did square was b over 2a. So we're gonna use it. So here you have b over 2a squared. Nice work. And then we have minus b squared. Now you can square it for a squared, plus c over a. Now it's just dealing with the It's gonna be just dealing with the last term. So with the last term, yeah, let me cook something very fast. You guys are grade 11s now. You guys are grade 11, so I'm gonna cook something very fast yet very slow. So I want to make my terms here, because I'm adding fractions. My terms, they have to be the same, so that means I'm gonna have to multiply here by what? I need a 4 and an a, right? 4a. So because that 4 is gonna give me the 4 and that a is gonna give me the a squared, ne? So yeah, now I have minus b squared over 4a squared plus 4ac over 4a squared. And now guys, I am done. I have this b over 2a minus, or maybe I can just say plus 4ac minus b squared 4a squared. Yes, I am done. Let me get rid of, no. Okay, cool. Okay, now I'm gonna have to multiply the a. Yeah, I almost removed the brackets and I forgot. No, that a is, it goes through everything. So now I multiply the a, it's gonna be a x plus b 2a squared plus, then I'm gonna have 4ac minus b squared all over 4a, because this a is gonna cancel out with the a squared. None. Yeah, we just have the a. So we are done now. And I want to show you something, guys. Right? P is equals to negative b over 2a. Ne? Yes. Or maybe let me go like this. X value of your turning point is x, which is minus p, which is minus 2b 2 over, yeah, which is minus b over 2a. That's basically how we get it. And different color, y value of your turning point is y, which is equals to q, which is equals to what? Which is equals to 4ac minus b squared over 4a. Right? So what have I done here? I've shown you guys formulas, and these are the formulas you're gonna use if ever they have given you an equation of a parabola, and they say what is the turning point. For you to find that turning point, this is just the formula you need. You don't need to derive it from the scratch. You just have to remember this right here, and you need to remember this right here, right? Remembering all of these, remembering these things, it's gonna help you a lot, because now you don't have to stress about deriving this thing from scratch. You can just remember, substitute, you get your turning points, and after you have done that, voila, you substitute or you draw. And also sometimes they will not ask you to find the turning point. They will say sketch this parabola, and for you to sketch it, you need your turning points as well. So these are the formulas you guys are going to use. Cool. We're gonna come back to this, but now let's discuss the second form. Believe this is the last form we have of a parabola. Oh, okay. The last form now. Okay, we see it's everything that we know. We have a, and then we have x. Then the question you guys can ask yourself is, what is x1 and what is x2? Let's deal with that. So yeah. Okay, there's a very important question for both of form 1 and form 2, and those question is, when do we use form 1 and when do we use form 2? So let me erase this thing. So these things right here, they are the what? X intercepts. Or x, yeah, they are the x-intercept, so the x values of your x-intercept. Because like in a parabola, then you have a parabola, there are two x values, but there's one y value for your intercept. For the intercept, for the x-intercept, y equals to 0, they usually like two values, but there are sometimes when there are no value at all, like say your parabola is something like this or something like this. In this case, oh no, here we do have, you have something like this. What am I doing though? We have something like this. We see that our parabola, they do not cross the x-axis at all. So in this case, we don't have the what? We don't have the x-intercept, and we will not use form 2. Form 2 can only be used when there are x-intercepts, right? Whether it's one x-intercept or like both of them are there, because there are cases here you have two x-intercepts, né? But there could be example where you have one. Say for example, no. Yeah, nah. Let me. Yeah. So you see here, né? You see here something happening. You have only one intercept. You can still use this one. Yeah, wanna so June. Yeah, you can still use this one. So I don't know what more to say about this one. That's what you remember. I was saying that this one is quite very easy, because even like when you use it, you before you find your a, you need two, or you need your x-intercept. Let me just say x-intercept or septs, right? You need your x-intercept or x-intercepts, and plus an extra point, and an extra coordinate. Yeah, plus an extra coordinate. Any point that is not your x-intercept will help you get a, and then you are done. I mean, that's all I can say about form 2. Form 2 is really simple. We're gonna do some examples, and we're gonna see like what exactly do I mean. So let me go back to form 1. Now form 1, remember with form 1, we've said some interesting things about P and Q that they tell us about your turning point. So when you know your turning point and you have an extra point, right? So you have your turning point plus an extra extra coordinate. You have your turning point and your extra coordinate, then you can use form 1, right? I didn't write it down, but always remember it, ne? Yes. Cool. So I believe this is just the end. Yeah, this is just the end of the parabola, but there are very important things that we have to discuss that we didn't discuss about parabola. So yeah, we're gonna go through the domain and range, turning points, x of x, symmetry, sketching the parabola. We're gonna talk about shifting parabolas as well. Yeah, and finding the equations of a parabola, right? Very cool. So where do I start? Let me go with the range first, ne? Maybe I draw a line. So for number 1, I'll use, let me go for green. For number 1, let's talk about the range of a parabola, which is the very simplest one, because the range of a parabola is like a range of a linear function, right? A range of a parabola, it's just gonna be, it's just gonna be from negative infinity to positive infinity, right? Or you can just say y is an element of, yeah. But yeah, me, I just used to write it like this back in my days. So yeah, there's nothing wrong with that. So that's just the range of a parabola. Because, oh guys, I'm lying to you, man. I am lying to you guys. I am lying to you. I am lying to you. I am not talking about range here. I mixed them up. My bad. I'm talking about the domain. because I was just about to draw the graph and show you why I'm saying from negative infinity to positive, and just when I had the graph in my mind, I saw no, 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 I am capping. Which means, of course, I'm lying to you guys, right? I am lying to you. So let's say we have a positive parabola here, and let's say maybe here we have a what? We have a negative parabola. Maybe much more space would help. I would do it here. Right, so you see here now your x values now. These are the x values, remember, these are the x values. So this parabola, it's pointing that way, this side it's pointing that way, and it'll go forever like this, and this side as well, it'll go, so that's why it's from negative infinity to positive infinity. It just expands. The same thing here, it will be going like this, and it will be going like this. So eventually when you expand it much further, you would realize that this thing, it will go to negative infinity, this one will go to positive infinity. That's what I'm saying. Domain is from negative infinity to positive infinity. Now, cool, very cool, very cool, very cool, very cool. The range though is quite different. Yeah, I was happy I was able to see that mistake. The range is very different. Range range depends on q, no, it depends on a, right? Depend on a. Now, if a is okay, we'll talk about a being, what is a here? A is negative a, and here we have positive a. Nah? So with this, let's draw this graph. It's something like this. Maybe let me just do this. Nah? And then here, right, you have your q, whatever it is, right? You have your q. So your range here, you see that your y values, they move from here, right, from this point, and they're gonna go downwards, because this thing I get it goes downwards like this, and this side as well. It doesn't matter which side. The y values, they will just keep on going down to negative infinity. So what does that mean? Here, if your a is negative, then you're gonna have a range here q. So q is gonna be included. Q is gonna be included. So it's from q to where? To negative infinity, right? And I'm sure now, let me make some separation in Canada. So and with okay, let me draw it. So with a being positive, let me start by erasing this one. So we have so this is our turning point, our q, right? Whatever it is in this side is negative, so it's our q, and our graph, it's gonna go straight like this, straight like this. The q values, they will never go below this, so they will move from here up like this. So in this case, what do we say? In this case, we have we have y being an element of what? They are from, we move from q to positive infinity. I'll open this one to positive infinity. Yeah, and I'm also realizing another mistake that I did. This thing is just a format, it's just a format. So let's fix it now. Do remember, guys, do not make this mistake that I did here, do not make this mistake that I did here. So when you give a range, you start from the lowest to the highest. Yeah, you start from the lowest to the highest, and it's clear that negative infinity is the lowest here, right? So this should have been negative infinity, and this should have been q, right, with a close bracket, because to draw it again, when we start at a particular q value, and then we go down to negative infinity. So it will be from negative infinity to q. Sorry about that. Yeah. So just remember, q q depends on a. If a is negative, this is how q is going to be. If it's positive, this is how it's going to be. The turning point, we've talked about it, so I'm gonna pause. The axis of symmetry, we've talked about it. Sketching, we're gonna talk about it. Shifting parabolas, maybe let's talk about it now. Cool. Let's talk about the shifting parabolas. So with shifting parabola, there are two shifts. There's a horizontal shift and there's a vertical shift. We have a good thing we have dealt with it. The easiest shift, the easiest shift, and when I say the easiest, I mean a shift which is not so confusing. It's the vertical shift, right? The vertical shift is the easiest shift, because the vertical shift, with the vertical shift, this is what we have. We have I'm gonna write it like this: y is equals to a x plus p squared plus q. This is a parabola you have, and then they tell you that your parabola shifted 4 units to the 4 units downwards. So if it shifted 4 units downwards, of course there on your graph you're gonna shift it 4 units downwards. But also now, about as for your equation, what does that mean? It means now our equation is gonna be y equals to remember what's the vertical shift? It's the q. So we're gonna take q and we minus 4 because it has shifted 4 units downwards. And if it did shift 2 units upwards, it's gonna be x plus p squared plus q, then plus 2, because now it shifted 2 units upwards. So that's how it is. But then as for what do we call this? As for horizontal, now I should always stick with this color. Horizontal shift, with the horizontal shift, it's gonna be a little bit different. So these guys, they tell you that your graph had shifted 4 units to the right. So we go here, y is equals to a x plus p. So what did they say? They said it shifted how many units? 4 units. Where? To the right. So to the right, x's are what? They are positive. But here we're going to subtract that 4. That's why it's a bit tricky. Remember, vertical shift is a bit straightforward. Horizontal shift is kind of not. Then you have plus q. And if your graph then shifts horizontally to the left, right, say shift 2 units to the left, is going to be plus 2 squared. Yep. Yeah, man. Yeah. So I'm gonna use these two graphs now to illustrate what we did say. So they are different, and which it's gonna help us broaden our understanding about parabola. With one parabola we have the turning point and one extra point. And then with this other parabola we have our x-intercepts. I'm not sure if you can be aware. We have both of them. Actually, we have both of them, both of the x-intercepts, but of course the other one is not shown, but it's there. And we also have our turning point there, I guess, as an extra point. So let's these are the things we're gonna start with. The what Let's talk about the domain and the range. So we know the domain and the range. Let me draw a straight line here. Maybe let me go that thick. Damn. Very cool, ne? Very, very cool. So number one, we talk about the domain. Domain of a parabola is just very easy, guys, ne? Yeah, domain of a parabola is just very easy. Negative infinity to positive infinity. You don't have to think about it. Yeah, but not so true. Negative infinity to positive infinity. You don't have to think about it. It's just very easy, ne? Very, very, very easy. And then as for the range, ne? The nicest thing, I'm glad that my graphs, they have different a sign, so the other one is positive, other one is negative. So yeah, it helps with the understanding. As for the range here, ne? As for the range, you see that y, it goes like from -3. Remember with the coordinates, ne? If I write the coordinates is x value and then it's y value, right? Yeah, so the second value is the y, the first one is the x. So now back to the first equation, the first graph. There on the first graph, I have a -3 as my q, as my what, as my q. Oh yes, guys, remember when I was saying that there are 2 points that I highlighted about q, that one of them was q being the y value of the turning point, one of them was q being the y-intercept, right? And I said they can be the same thing or they can be different things, and you see here in both equations, in fact, our turning point, our y value for the turning point is not the same as our y value for the what, for the y-intercept. So yeah, here, and it goes, okay, in the side we go from -3 and we go down to negative infinity. So here I will say negative infinity to q, no, to -3, and we close -3, we open negative infinity. This side, we move from 4 going up to positive infinity. So here the range is gonna be something like this. We close, or we include 4. It's gonna be from 4 to positive infinity. Then we are done with your range, right? That's domain and that's the range. What's number 2? Number 2 is the turning point. They gave us the turning point here. Yeah, so let's just skip that one. Axis of symmetry. Axis of symmetry, remember, the equation is x is equals to minus p, which is what here. Okay. So this line, this equation, we use it if you are just given an equation, but if you can see it, you don't have to go through all of this. If you can see it, you just look at your graph and you say, okay, -1 is your what, is your axis of symmetry, because in this equation, when we draw a straight line here, cutting there by x is equals to -1, we're gonna have two identical sides on the left and on the right, right? So for the second graph, they did, I don't know why I did that, but it's gonna be what, it's gonna be x is equals to 4. Let's talk about the other sketching. We are not sketching because it's already been sketched, and shifting parabolas. This is just gonna be a lot of work, just shifting it. No, I'm not gonna do that one. It's just gonna be a lot of work, and I think even a grade 8 kid can shift this graph however units, to the left or to the right. But the shift that matters the most is what, is the shift that is what is the shift, man? It's on the equation. If you're just doing the shifts on the equation, that's the most interesting one, right? But yeah, also just learn to shift them, by drawing them. It's quite easy. But yeah, and finding the equations. So we're gonna find the equations now, and we're going to redo these steps again now with the equations. So yeah, this is something also very, very important. It's very, very important. This is now me showing you guys the difference between form 1 and form 2. Number 1, or equation, or the graph number 1, we have a turning point, yes, and we have an extra point, right? So yeah, let's go on with it. Oh damn. Let's go on with it. So 3y is equals to ax plus p squared plus q. Ne? So this is how I start. I don't know a yet, and then x. Let me leave it like that, and plus. Let me start with q. Q is the y value of the turning point, which is what? Which is minus 3. So I'm just gonna write minus 3 here. Yeah? And now let's talk about p. P gives us the x value of the turning point. It's minus 1. So we're gonna say what? Minus or plus? Think about it. Are we going to write minus 1 or plus 1? Think about it. Plus 1. Because there it's minus, so we write plus 1. And now there is one thing missing, is a. How do we find a? We use this extra point given to us. Ne? So substituting that extra point, we have minus 3.5, and we have a, we have 0 plus 1 squared and minus 3. Yeah. So now I can transpose the 3. I have 3 minus 3.3.5, and then here I'm just gonna have a. I'm just gonna have a. So now we go to the calculator. We say 3 minus 3. No. Maybe let me just do this. Shift. Voila. There we go. There we go. And then we can say what? We can say therefore y is equals to minus half into x squared. X plus 1 squared minus 3. And we are done finding the equation of this one. We are done. Eh? Yeah. So let's find the equation on this side. So on the side, number 2, when you look at it, we have the turning point, and we have another point, which is just a point here, which is what? This point here, I'll write it in red. This point here is 1 and 0. So you can say because we have a turning point and that extra point, you can use form 1, right, like we did on number 1. But also now here's the thing, you have also two you have your two axes, x-axis. So we're gonna use form 2 here. I mean red is fine. So it's a x minus x1 x minus x2. Let me take a so why do I say that? And also, like, now when you go on with this formula, you write a, then it's x minus the first intercept, it's gonna be 1, then x minus the second one, which we do not know, but we know it's here. So remember guys, now we spoke about the axis of symmetry, which cuts a parabola into two identical sides, and in this case our axis of symmetry was 4. So, and now from this intercept it's 1, and then here it's 4. That means there are 3 units here. So that means for us to get this point now, it's just gonna be 4 plus 3, which is 7. So this point here it's 7. So I just decided not to write that one, just to make it interesting. So you have both of your x-intercept, and then y. So and then maybe, like, while we are here, we will go back here. While we are here, so that you don't make things complicated for you, use that extra point to find what? To find a. So that extra point, we have minus 4.5. A, we have 4 minus 1. We have 4 minus 7. and then at and a half, and then it's gonna be a here. This side I have 4 minus 1, that is 3. Yes, it's 3, and then 4 minus 7, that is also 3. But it's a negative 3. Negative 3 times negative 3, and yeah, 3 times 3, actually it's 9, so minus 9. So now I'm going to divide everything by minus 9. So I'm gonna get a positive a. So I can say what? I can say minus 4 divided by, divided by, maybe let me say, divided by minus 9. The answer is what? The answer is half. No? Sure. So what does that mean? Therefore, you have y is equals to half x minus 1, x minus 7. And now maybe I will start expanding. I'm gonna have x squared. I'm gonna have minus 8x. I'm gonna have plus 7. Then I can just start distributing my half. Minus 8, which is 4x plus 7 over 2. And then, guys, I am done. I am done with these. Am I done? I feel like there's something that I did wrong here. Because there's something which is not making so much sense. Let me see. That's positive 7, yes, of course. Yes. Yeah, there's something that doesn't make sense here. Because our graph is positive, so it makes sense A is yes. But here, there's something. So I substituted 4, so 4 minus 1, that's 3, and then here it's minus 3, so minus 9, so we divide, so we get positive, so and positive 7, so if we make x's to be 0. Oh no, everything is fine, everything is fine, guys. Yeah, so I didn't notice. So let me tell you what was going on in my mind, né? So I looked at this number and I was like, no, this number is positive, né? It's positive, which is 7 divided by 3, it's 3.5. It's positive 3.5. But then when I was looking at the graph, né, I'm like, Kaibo, no, I have a negative y value here. And then I forgot the point I was saying so many times. I forgot that, remember, a turning point, a y value of a turning point is not always the y value of the y-intercept. Because now that value 7 over 2, ne, that positive is the value here, right? And it's positive. It's the y-intercept and it's positive. So me, I was so confused. I'm like, no, what's happening here? Yeah, well, yeah, so now let's do something also quite interesting, eh? Let's do something quite interesting. So you can have a parabolic equation like this, in this form, right? You'll be given this form of a parabola and they will ask you, they will say, give us this parabola in form 1, ne? Give us this equation in form 1. I'm gonna show you guys how to do that, and you guys must know how to do it as well. Yeah, when I saw you. So I'm gonna do it on this side. So I'll be doing it on this side. So yeah. So remember step 1. Step 1 is to make sure that the coefficient of your x squared is 1. So it goes back to it being half x squared plus minus 4 minus 8x plus 7 plus 7. Yeah, so now I take the middle number. I'm gonna divide it by 2. The coefficient of the middle number, I'm gonna divide it by 2. So when I do that, I'm getting what? I'm getting 4. So I'm gonna add it. I'm gonna square it and then add and subtract. So I have 4 squared, which I'm adding, and I'm subtracting 4 squared. Alright, and plus 7. Then I take the first 3 terms, and with the first 3 terms, 1 over 2. With the first 3 terms, what's gonna happen? Yeah, with the first 3 terms, it's something interesting, eh? This is something interesting because that's where we're just gonna write x. This sign here is negative, so we go negative and we write the number we see here, which is 4. We don't have to think about the the third step. So yeah, and then we have minus 16 plus 7, 1 over 2 x minus 4 squared minus 9. Then we multiply the half. You have half x minus 4 x squared minus 9 over 2, which is what? Which is a half x minus 4 squared minus 4.5. Let's look back. It's 4.5. It's 4.5. It's 4. It's 4. Nah, you see, it makes sense. Everything makes sense. Nah, if they were to say what is the turning point here, looking at this graph, you're gonna say my turning point is 4 and minus 4.5. This is what? This is my turning point. Yeah, Bona. Yes. So yeah, this is parabola, guys. This is parabola. Oh, something I said I'm gonna do and I didn't do. For some interesting vibes, and since here we have the turning point and an extra point, you can use either this point as an extra point or this one as an extra point. Try to use form 1 to find the equation and see if it matches the equations that we got. Try to see if it matches the equations that we got. So here I'm gonna try to shift our equation. Maybe I'll go with number 1. I'm gonna use this one for the shifting. So the original is just 1 over 2 x plus 1 squared minus 3. Say now they say it shifted 5 units upwards. So upwards, that is vertical shift. So my focus is gonna be on Q. So 5 units upwards is gonna be minus 3 plus 5, and the whole thing then is gonna be end up being it's gonna end up being 2. So this will end up being a plus 2. If they say it shifted 3 units to the right, then I know it's a vertical shift. Then I have this plus 1 to the right is on the positive side of the axis, so I'm gonna say minus 3 squared, then minus 3 minus 3 minus 3, right? And then you just do the math there very quick, and then you have done. Yeah, so this is the end of parabola. Parabola is a lot, and this is the longest video I've taken so far. Damn. But yeah, parabola is a lot, guys, so just I hope you did understand everything we did, and don't worry, there are many examples we're gonna do, right? Talking about parabola. Always. See you in the next video.